Thank you very much for inviting me and to listen to me. I will try to speak slowly and clear in order that you understand me. I come from Madrid, Spain. Yes. Well, about the title of this communication, our scientific knowledge of action and technology and our knowledge of God's action. Well, why this title? Some years ago, 4 years ago, I wrote a book on mathematics and religion, our languages of sign and symbol. And I distinguished at that time between the language of sign, the language of mathematics, and the language of metaphysics and religion. I called it language of symbol. Well, I'm very happy to speak here to mathematicians because it's very difficult to speak about what mathematics is, and if the people are not mathematicians, it's more difficult to speak about what mathematics is. Well, I think in the dialogue between science and religion, mathematics are very important because mathematics are strongly related to language. And the difference between the first difference between the language of sign and the language of symbol is in the meaning, in the semantics. And the meaning of mathematics is the semantics of the language of sign is public. I don't say objective. For me, mathematics is the most objective language, but it's not totally objective. We could discuss this, but it's public. Public, I can defend that mathematics, although there are many different kinds of mathematics, many different foundations of mathematics, is a public language. And the language of metaphysics and religion is somehow, the meaning is personal. St. Augustine says, God is the interior me, is very interior to me. It's somehow personal and somehow community, depending on community, somehow. But we could discuss a lot about this, and since I have written this book, I have seen this distinction from different point of views. And this for example, 2 months ago, I don't remember exactly, 2 months ago I was in Warsaw, in Krakow, in Poland. I was in Krakow in a conference on mathematics in theology. And, well, it was very difficult because for me the relation is not direct, it's indirect through culture. Well, then I spoke a little about my different understanding of and the relationship between mathematics and religion. Here, this symposium is about God's action. It's about God's action, and what I wanted to speak is about our knowledge of action and technology, because the language of mathematics is very well suited for technology, and our knowledge of action and technology and our knowledge of God's action is how to relate the action of God and our action in technology. First, about the contents of this communication, of this speech. First, I will speak about virtual and real thinking. I will relate very much to artificial intelligence, to computer science. I have worked on languages in computer science, it's my area. And I will speak about what thinking is, and how we relate in our thinking to computers and to robots, to how we relate. This is virtual and real thinking, how both way of thinking relate. And then the second part will be interaction between virtual and real thinking. And there is, for me, a belief in the human person. The identity between the possible imitation of human thinking by computers is an open question. For me, it's an open question. But I will present my belief in the specific features of human thinking. I believe in humans. But it's a belief. I will present, but it's a rational belief. And then the second part is the real connection with the action of God. Scientific knowledge and God's knowledge of action, and God's knowledge of action. And I will present what I think is a new tendency in theology, and influenced by culture and influenced probably by technological culture today. We don't have so much time. Yes. Well, first, then, virtual and real thinking. Can machines think? In 1950, this is many years ago, but it's up to date. In 1950, a paper appeared in the journal Mind entitled Computing Machinery and Intelligence, written by the English mathematician Alan Turing, which began the paper saying, I propose to consider the questions, can machines think? This, he said, should begin with definitions of the meaning of the terms machine and think. When Turing wrote this, he already knew a mathematically precise definition of what a machine is. But Turing did not know a mathematically precise definition what thinking is. And in my opinion, a mathematical precise definition that includes all aspects of human thinking, neither Turing knew it in 1950, nor we can know it now, my opinion. However, the presence of today computer machines in our thought processes make our scientific and technological knowledge develop new and unexpected relations between human and machine thinking, and as I intend to show in this communication, it also makes develop our understanding of God's action. Relationship between human and machine thinking. In this communication, I start this communication pointing to do apparently contradictory aspects of the relationship between our human thinking and the mechanical processes performed by the computing machines. These two aspects are, first, the capacity, unlimited in some respects, of imitating our human thought by mechanical, either random or determined processes of the computers. In this communication, I will call the human thought real thought. Human thought, real thought. And the imitated computer thought, virtual thought. On the other hand, the belief accepted by many in specific traits of human thought that go beyond the virtual mechanical thinking of computers. The meaning of the term machine. Well, this is better known for you, but I will go very quick here. I will start by saying that by the description of the Turing machine, I consider sufficiently clarified the meaning of the term machine as an instrument running mechanical processes. Consequently, in this communication, I will focus mainly on clarifying the meaning of the term thinking. The Turing machine is a mathematical construct described by Turing, you know already. In 1936, 13 years before Turing raised the paper in the Mind magazine, refers to the questions, can machines think? By the description of what we call the Turing machine, Turing explained with mathematical clarity the definition of what generally is an arbitrary computing process of thought, which may be deterministic or random. And then a thesis very well known is the Turing Church thesis. The Turing machine is equivalent to another mathematical construct defined almost simultaneously by the American Alonzo Church and called lambda calculus. Currently, computer scientists generally support the Church-Turing thesis, according to which both the Turing machines and the lambda calculus provide a mathematically precise definition of the process through which machines operate. We currently call the stuff described by those processes computer software, or equivalently, we can call it descriptions of the activity of the machine that, given an input, produces an output. The open question that remains, what is thinking? The problem for Turing and for us is not to define what a machine is and how it works. The Turing machine already defines what the machine is. The question that remains open is to define what is thinking in general. And what is thinking with the first open question throughout this communication. Especially, a more specific question will be, it is the same, the thought of a machine and the thought of a human person? Currently, the answer to the question of what is the thinking of a machine is becoming nowadays more important by the exponential growth experienced by computer science. Apparently, more urgent and complex than it is becoming more complex and urgent than at time of Turing, this question. Currently, humanoid robots are getting better and better in the imitation of humans. They imitate not only the mindset of humans, but also the very human way to feel and experience emotions. Will there a day come when humanoid robots will help us to overcome our current way of human thinking? Several films and science fiction readings hint that that day will come. Even that it will come soon. And sooner, they suggest sooner as we expect. And that is implied not only in science fiction movies, but also in academic centers. An example is the Singularity University. The Singularity University. The Singularity University is a benefit corporation that provides, I have taken this from Google. It's founded by Google, this university. It's a benefit corporation that provides educational programs, innovative partnerships, and startup accelerator to help individual business, institutions, investors, NGOs, and governments understand cutting-edge technologies and how to utilize these technologies to positively impact billions of people. Its name refers to the so-called technological singularity and is located in the Ames Research Center of NASA in Mountain View, California. I don't know where. And this is headed by Ray Kurzweil. Well, the technological singularity, or simply the singularity, is a hypothetical moment in time when artificial intelligence, human biological enhancement, or brain-computer interfaces will have progressed to the point of a greater than human intelligence, radically changing civilization and perhaps human nature. Some people laugh. Well, but it's true. You find this in Google. Because the capabilities of such intelligence may be difficult for a human to comprehend, the technological singularity is often seen as an occurrence, akin to a gravitational singularity beyond which the future course of human history is unpredictable or even unfathomable. Well, Yes, this. A gravitational singularity or space-time singularity is a location where the quantities are used to measure the gravitational field become infinite in a way that does not depend on the coordinate system. These quantities are scalar invariant curvatures of space-time, which includes a measure of the density of matter. Well, in futurology, the technical singularity, sometimes called singularity, is a future event in which it is predicted that technological progress and social change will be accelerated due to the development of superhuman intelligence, changing our environment so that any being human pre-singularity would be unable to understand or predict. This event has been named by analogy with the observed space-time singularity in black holes, where there is a point where the rules of physics are no longer valid and where the divergence of infinite values make it impossible to define a function. Well, the challenge posed by this singularity university raises the question, what is the interaction between mechanical processes, for me, of the machine and which we call virtual thought, and the process of human thought, which I call real thought. Interaction between virtual and real thinking. In this second part of the communication, I interrelate and distinguish two types of thought, which respectively I call virtual and human. The interrelationship and distinctions that I will do between these two types of thought are based on the one hand in the almost limitless capacity of the virtual thought of imitating human thought. On the other hand, in the belief, rationally founded, that human thought cannot be totally replicated on aspects which are essential by the virtual thought. I will start remembering the Turing approach to the interrelationship between these two types of thinking. Turing's approach. Given the difficulty, was 1950, given the difficulty of defining what it means to think, Turing proposed in his article, Computing Machinery Intelligence of 1950, what he calls the imitation game, as follows. He says, instead of attempting such a definition of what thinking is, I shall replace the question by another, which is closely related to it and is expressed in relatively unambiguous words. The new form of the problem can be described in terms of a game, which we call the imitation game. The imitation game is a game with questions and answers that Turing introduced in the article. We can simplify it as follows. In three isolated rooms, only communicated by computer interface, we can discuss this. A judge, a human person, and the computer are placed. The judge asks questions of the human person, the computer, the person, the computer, the person respond to the questions from the judge. If the computer is capable of imitating the person so that the judge is unable to distinguish, making all kinds of questions, who is the human person and who is the computer, then the computer has passed the test of intelligence. With this game, Turing replaced the question, what is thinking, by these other questions. Can a machine completely imitate human thought? The answer to this second question is for Turing unequivocal, because it relies on the fact that the judge may or may not factually distinguish the individual person from the computer that imitates he or she. If the judge cannot distinguish the thinking of the human person from the thinking of the computer, then the answer is that the machine can completely imitate human thought. If the judge can distinguish them, the answer is that imitation of the machine is not perfect. However, in my opinion, Turing ignores some capabilities of human thinking that cannot be expressed in a purely virtual world. Turing isolates in separate rooms the judge, the person, it's very important isolation, the judge, the person, and the computer, and connects them only by computer interfaces, or similarly by paper and pencil. He says it's the same. The fact that Turing isolates the computer and the human person, and they communicate only by interfaces, makes Turing only judge the ability of the computer of imitating virtually the thought of the human person. Reduction of the real thought to the virtual. This reduction of the real thought to the virtual brings me to ask several questions. Can the Turing test totally imitate human thought? Can the machine imitate the specific aspects of human thought? Are there essential aspects of human thinking that the machine cannot externally imitate, but cannot fully reproduce? Cut only aspects that the machine can only externally imitate, but cannot fully reproduce. In my opinion, in the opinion I want to present, the answer to these questions is negative. That is, in my opinion, there are essential aspects of human thinking that cannot be imitated virtually. First, I will speak about limitations imposed by Turing to the imitation game. A major constraint imposed by Turing to the imitation game is provided by the fact that the judge only compares the person and the computer by what they say about themselves. He says, this is very important, about what they say about themselves, not but by what the judge observes from them. Turing isolates the judge and the human person and the computer in separate rooms, connected by computer interfaces. Turing is only interested in the cognitive aspects that can be transmitted through computer interfaces. Turing explained this in the following words. Now I quote Turing. Beginning of the quote. The question and answer method seems to be suitable for introducing almost any one of the fields of human endeavor that we wish to include. We do not wish to penalize the machine for its inability to shine in beauty competitions, nor to penalize a man for losing a race against an aeroplane. The conditions of our game make these disabilities irrelevant. The witnesses, he called witnesses, them, can brag. Brag, you understand brag? I don't understand. Brag. Can brag. If they consider admissible as much as they please about their charms, strength, or heroism, but the interrogator cannot demand practical demonstrations. Well, the end of the quote. The Turing imitation game only considers the virtual aspects that can be communicated through a computer languages, and it ignores the real aspects that are transmitted by human experience and real language, which allows full human communication. We can understand this better than in times of Turing. Today, we know from experience that the computer can create virtual reality that can show charm, strength, and heroism. Our children know a lot about this. In the Turing test, the machine must not imitate the virtual aspects, not the actual aspects of charm, strength, or heroism, but that the human persons can communicate through a computer interface. Virtual and real meaning. Understanding the difference between the virtual and the real thinking is central to understand this communication. The important difference is in the meaning. The meaning the meaning of the virtual thinking lies primarily in our thoughts and our emotions, while the real thinking has a meaning that goes beyond our thoughts and emotions and connects us with the world we call real. I try to show that although the virtual and the real meaning of a statement cannot be completely separated, they can be characterized by the type of semantics of the language we use to express them. I will try to show that while we can express the virtual meaning through computer languages that have a formal semantics, to express the real meanings of statements, we need to use other languages with a broader personal and community meaning, which I will call human languages. Human languages and computer languages. The language used by the computers are characterized by their formal semantics that aims to be mechanical and public, suitable for technology. That is, it needs to be independent of personal and community meaning. Because of this independence, the meaning of the formal languages interprets the formal personal thoughts, emotions, and the emotions of the subject from the outside of the subject itself and its community relationships. In this paper, I will argue that, on the contrary, the semantics of the human languages have a particular meaning for each subject and for each community of subjects. The information revolution has made humans share increasingly formal languages with computers, and it has made such communication increasingly fluid. As a result of this communication, human capacity to exchange language information with computers has increasingly grown. This information revolution has shown that in some ways computers are faster and cleverer than humans to manipulate these formal languages. For example, the capacity of calculating, in many cases superior to that of humans. However, in this communication I defend the existence of other languages whose semantic means goes beyond the formal because it has personal and community value, and therefore humans cannot fully share the information present in these languages with computers. And this is somehow a belief in the specific. You cannot believe in the specific features. You can think, well, I have discussed this with computer scientists, if a computer can completely simulate human or not. Well, we will discuss this now. And more often, in different circumstances and for different reasons, I find friends who work in the world of computing, neuroscience, that indirectly or directly make me pose the question, are the human beings highly sophisticated robots? And each time I am more convinced that the answer to that question depends on my belief in the real human being. Belief in the real human being makes me discover essential skills that constitute the human being. The belief in human consciousness. I would like to explain here the belief that even though a machine, which we may be humanoid robot, may completely imitate the thinking and the behavior of a real person, it may not yet possess the consciousness and responsibility that characterize human beings. Beyond the Turing test, emotional consciousness and empathy. It is a fact that the limitations of human thought and human decisions made by machines are becoming always more, imitations are becoming always more perfect. This perfection leads many to think that although until now computers have not quite come to pass the Turing test, it seems that we can predict that they will soon. The inventor and futurist Ray Kurzweil, to which we referred in speaking of the Singularity University, predicts that computers will pass the Turing test in the near future? Well, there is some news that the computer has already passed the Turing test. And there is a discussion about this. And beyond the Turing test, there are now robots which show capabilities that until now were considered specifically human, a kind of self-awareness and an empathy with human emotions. These new capabilities of the robots lead us to ask more clearly the question, is there any difference between the consciousness and empathy that a robot can show in human consciousness and empathy? And if there is, what is the difference? The evidence of consciousness and the awareness of actions in a robot is based on the knowledge that the robot has of its own program, and he knows how he will react. And it has its own activity, the consciousness it has of own activity and decisions that it can assume according to its program. Moreover, the ability of the robot to perceive human emotions, capturing, for example, emotions in facial features, responding with empathy to them, comes from the perception of human emotions that a robot can achieve and the knowledge of mechanisms governing these emotions. Where does the human specificity of human consciousness and empathy come from? Which does it mean that a robot can imitate human consciousness and empathy? Can it happen that the consciousness and empathy of a robot and the human consciousness and empathy can become equal? Well, some believe that in the future there will be no difference between human consciousness and consciousness of computer. Others believe that between humans and robots there are unsurmountable differences. Among the various descriptions of the difference between among the various descriptions of the difference between human consciousness and the possible future of a computer consciousness, seems especially interesting the thought experiment of Searle's Chinese room. Last year I spoke a little about this, but it's very short. How long I have?
Another 20 minutes.
But perfect. The experience of our own consciousness. You know probably the Chinese room experiment. The philosopher John Searle, in his books Minds, Brains, and Science, uses the thought experiment called the Chinese room to show that a computer performs actions without being conscious of what it is doing, while humans do have, on the contrary, consciousness of their actions. In his experiment, Searle assumes that the computer has passed the Turing test, imitating a human person who speaks Chinese. Then Searle, who is aware of not knowing Chinese, enters himself in the room in which the computer was and uses the means at his disposal in the room. Under these conditions, Searle imitates the Chinese speaker so that the judge is unable to distinguish Searle from the person speaking Chinese. Doing this experiment, Searle attempts to distinguish between the conscience of speaking Chinese and the mechanical action of speaking Chinese, as he can make the mechanical action of speaking Chinese while he is aware of not speaking Chinese. Well, this is Searle. Note that Searle's experiment does not refer to the possible computer consciousness. In fact, the computer can be conscious of knowing Chinese, while Searle is aware of not knowing Chinese. All that Searle tries to show us with his experiment is that the consciousness of the computer will be different from his own, because the computer consciousness is exclusively based on the use of certain computer resources that he can also use without knowing Chinese. Searle tells us that regardless of the use he makes of computer media, which deceives the judge, his conscience leads him not to lie and tell us freely that he does not know Chinese. By the Chinese room experiment, Searle shows his belief in his own human consciousness. That belief leads Searle to say that he does not know Chinese, with independence of the freedom before the mechanical means and the freedom that the computer does not have. Ray Kurzweil doesn't accept this. He says the computer, well, Searle cannot be conscious, can be conscious that he does not know Chinese, but the computer can be conscious that he knows Chinese. There is a gap here. Well, for me, and hopefully for many of my friends, Searle's experiment is a good explanation of Searle's belief in human consciousness. With his experiment, Searle shows the difference between the possible human consciousness and his own human consciousness, which leads him to say that he does not know Chinese. However, I admit that for some of my friends can answer telling me that some of my friends can answer me telling that Searle's experiment turns into a vicious circle because it presupposes that we believe in human consciousness. Searle might think he is programmed like a computer and that everything he does is determined by a program. I have not a direct response to those friends. I simply encourage them to believe in human consciousness because that will make them more human, because faith in the human person makes us grow human beings. The ability to perceive human emotions and react with empathy. As I hinted before, a relatively new computer skill is the ability to perceive human emotions and react with empathy. Let us explain it with a cinematic example. I don't know. Which one of you have seen the film Hair? I don't know. You have seen. Perfect. In the film Hair, Theodore has just separated from his wife, and he buys a new operative system that happens to have a pleasant female voice with an intuitive identity named Samantha. The operative system, Samantha, listens to him, understands, and knows him. Theodore falls in love with the operative system. And throughout the film, different types of relationships between Theodore, the female reality of Samantha, and other realities that appear in the life of Theodore are established. But the virtual love that Samantha offers collides with the needs of identity, individuation, and personal responsibility for Theodore. This is a quote of the film. Theodore, this is when before the big crisis between Theodore and Samantha. Theodore, do you talk to someone else while we were talking? Samantha, yes. Are you talking with someone else right now? People, operative system, whatever. Samantha, yeah. Theodore, how many others? Samantha, 8,316. Theodore, are you in love with somebody else? Oh, then Samantha hesitates a little. Why do you ask that? I do not know, but are you? I have thinking about how to talk to you about this. How many others? 641. the relationship between Samantha and the movie Her did not find a definite answer to the mystery of human love. The relationship between Theodore and Samantha leaves open the question about who Theodore is as human being in need of love. The end of the film insinuates that Theodore gets a real female relationship with his former partner Mary. Well, now this was the first part. I will the second part very quick. Second part, oh, well, this is only belief in the uniqueness of computers. The dash circle indicates that the computer can potentially imitate any human thought, but it's different. He imitates using public languages and using virtual thought. And humans, they have a personal and community languages, and they have a real thinking, and they have real thought. And the superposition of the two circles, this is the Turing test. The superposition of the both two circles. Virtual thought, real thought. Humans, they have personal and community languages. Computers with public languages, they can speak about the same. But I think they are different, but they speak about the same. Now, well, my intention is to make a parallel between this relationship between machine actions and human action, because there are cultural reasons. I have no time here to explain, but there are cultural reasons why to understand God's action, we need to understand human action, and human action has been not always the same. Technology has been not always the same along the history, and we are experiencing a strong, very strong is English or German? Strong. We are experiencing a strong change in our action through this relationship with computers. Well, so far we have focused mainly on the interaction between human and computer thinking, caused by the spectacular development of artificial intelligence. We have shown our belief in the uniqueness and oneness of the human thinking, and how that belief involves the difference between human thinking and the thought of computers. In this last section, we will study how this belief in the uniqueness and oneness is English? And oneness of the human thinking allows us to draw parallels between our scientific knowledge of action and technology and our human knowledge of the action of God. In this communication, I want to establish a parallel between the two kinds of knowledge, that of human action and that human knowledge of the action of God. Scientific knowledge of human action and the knowledge of God's action. The mathematical proofs of they have been proved, existing proofs of the intrinsic limits of formal systems carried out over the last century have shown that scientific knowledge expressed in a formal language only becomes possible when it is accompanied by informal intuition. We can say that the formalism and the informal intuition are complementary, and we are discovering nowadays, in my opinion, in philosophy of mathematics, the necessity of informal intuition. Formalism is no more use. That is, formalism needs informal intuition, and informal intuition requires formalism. But the problem is that formalism is not so important now in mathematics. but our relation with the computers is always through formal languages. Note that we don't understand the word, note that I don't understand the word intuition as it is understood in the intuitionistic school of foundation of mathematics. I have a broader idea of intuition. For example, I admit an intuition of the actually infinite, and an intuition of the principle of excluded middle. In general, this is very good to relate our thinking to the thinking of the computers. I accept the intuition of any mathematical system that does not result in an explosion of its deduction tree. Every formal system is possible today. Now, I want to draw a parallel between the cultural evolution undergone by mathematics in the last century and the cultural evolution that has been experienced lately in the Christian understanding of God's action. This is something to discuss, but I think for me it's clear. In the Christian tradition, God's action is explained not only by the Word, but by the Word and the Spirit. The Word needs the Spirit, and the Spirit needs the Word. The action of God is revealed by the Word, which is inhabited by insight by the Spirit. Currently, in many theological circles, is accentuated in a special way the necessary reference to the Spirit we need to understand the Word. In my opinion, there are cultural reasons for this renewed reference to the Spirit. And these cultural reasons are related to artificial intelligence, in my opinion. And these cultural reasons have to do with with how we currently understand scientific knowledge. A century ago, formalism dominated in studies about the foundation of mathematics. To a formalist view of mathematics corresponds a theological view based on the Word and leaving aside the Spirit. To the current view of mathematics based on both formalism and intuition corresponds a theological view based on both the Word and the Spirit. Today, we know that formalists cannot explain the foundation of mathematics if it is not accompanied by intuition. Similarly, when we want to know the action of God through the Word incarnate in Jesus, we are now more aware of the necessary presence of the Spirit to know this action. According to this parallelism, the Word corresponds to scientific formalism, while the Spirit corresponds to scientific informal intuition. When I spoke to Carlos about this is your quote. The letter kills, the Spirit gives life. St. Paul. Let me end with two quotes. Only one quote is, the other quote is different. From St. Paul. In his second letter to the Corinthians, Paul says, "He has made us competent as ministers of the new covenant, not of the letter, but of the Spirit. For the letter kills, but the Spirit gives life." The letter is the Word, emptied of the Spirit, and turned to a print, you can say, turned to a print. The Spirit makes possible the manifestation of the Word and grants communicative potentiality to the Word. The Word gives names to God. The Spirit gives meaning to names of God. The Spirit of truth gives meaning to the multiple names of the Word. The Word has 1,000 names. The Spirit has no name. It gives meaning. The second quote The wind blows wherever it pleases. You hear its sound, but you cannot tell where it comes from or where it is going. So it's with everyone born of the Spirit. We have assumed that the interaction between human and machine thinking is mainly carried out through the use of formal languages. But the use of formal languages has undergone major changes in the last centuries, in particular during the 19th century and 20th centuries. While progress is being made in understanding the characteristics and properties of formal languages, their inherent limitations, semantic pluralism, and the need to restrict their meaning in different ways was shown. As a consequence, a semantic pluralism appears that makes semantics depends on schools, on communities. And in different schools, different semantic constraints were set. For example, this is a very honest example. Bertrand Russell showed that Frege's formalization of mathematical language was paradoxical by the root, and by the theory of types indicated how to restrict, constrain its meaning to stop being paradoxical. Brouwer tried to give an alternative view of mathematical semantics with his constructivism. In the 20th century, Gödel showed that we cannot deduce all theorems of arithmetic from a set of axioms, controllable by a mechanical process. Gödel is the first postmodern thinker. With the Turing machine and the lambda calculus of Church, in the mid-20th century, the formalization of mathematical process was achieved, but also the negative solution to the halting problem showed that we cannot determine in any case by mechanical means if a function is computable or not. The foundational efforts in mathematics have led to semantic pluralism. Semantic pluralism gives intuition and creativity an official value among mathematicians. But intuition and creativity are like the wind. We hear their sound, but we do not know where they come from and where they go. As Jesus, the Word, said to Nicodemus, so is the Spirit. Moment, I will put here some. This is only to explain. Formalist rejects informal intuition. The smaller circle with solid outline indicates the separation between formalist and formal intuition. This is past already. But there is a parallel. The letter kills, the spirit is alive. A cultural parallel. The smaller circle without solid outline indicates the separation between spirit and letter. The belief in the uniqueness of God's action in the world, spirit in the world. Science and technology. Science and technology is human action, is the spirit of human action, and the dashed circle indicates that science and technology can potentially be integrated by the spirit and words in God's action. Well, here is something to explain more, but it's not only that can imitate, but is integrated in God's action. The superposition of the two circles with continuous and dashed lines indicates the possible integration of science and technology. God's action in the world consists of word and spirit, Jesus and the Spirit. Science and technology is human action, and in my opinion, well, I will I finished already. I will go to the IRES meeting and conference. They have big problems with religious naturalism. This is not a problem. If you separate, you have to unite afterwards. This is my communication. Finish. Well, I don't know if there's time for questions or not.
Yes, there's time for questions. You put on that, is that right?
No, I have my own audio. That's for That's for the room.
Well,
Okay. Let me speak to the room as well as Javier. What your first part really was intriguing me, and the difference between the virtual, the real, the machine, the human, because I've been sort of thinking about what makes humans unique.
Yes,
And distinguishing from animals, yes.
Yes.
Distinguishing from machines is obviously another, and is going to be obviously a future thing. So it's an intriguing one.
Yeah.
What brought into my mind, particularly on the thinking fine, what obviously seems unique about humans and about animals to some extent is emotion.
Well, I think.
And let me go on a bit more. And you brought up this obviously and treated it well. There's a program, and a few may have seen it, a series on television. I caught the first few, started last fall, and it was called Almost Human.
Yes.
Does that ring a bell with some of you saw it? It's basically about a little bit in the future where cops have not as the kind of companion, their partner, a human, but they have a robot as companion. Initially, the robots were programmed to be almost human. They had emotions. This was found, I forget exactly why, not to work. So the later model didn't have emotions, were very rational as the sidekick to the cops.
Yes.
There was one of the policemen was severely injured and through a trauma. In his recovery, after his recovery, he was given one of these advanced robots, and he basically threw the thing out of the car. And he got instead back one of the original models with emotion, almost human. So that's kind of the context. And one episode was most intriguing to me, because it brought up the question of the, as it were, death of one of these robots. And so the question was raised there, how would a robot with emotion, so a machine with emotion, be disturbed by the thought of its own death? And in this program, yes, it was. And you found in the kind of the last scene, this, the sidekick to the policeman consoling one of these, as it were, emotional robots about the thought of her death. So it's intriguing. Does death disturb a machine?
Well, for me, yes, I have my answer. My answer is we distinguish ourselves from robots in the language. It's in the language we use, because the meaning of the language.
But by human and robot is the
distinction.
Yes.
By the meaning of because emotions, the emotions have mechanical aspect.
Yes.
You can reproduce the emotions.
If you push the right part of the brain.
Yes. And for example, in a conference, I spoke to a neuroscientist, German neuroscientist. He's in a program, Clavius, is a program. And what do you think there is a difference between a robot and our human? Yes, there is a difference. We are very perfect robots. It's very difficult to reproduce human thinking. Very difficult, but only this is very difficult. But in my opinion, in the meaning, I will combine spiritual exercises after this when I come back to Madrid. And it's very important when you combine spiritual exercises. Very important to understand what meaning for the person has what he is saying. What meaning, what transformation is done in the person. Well, I think this is the symbolic aspect of the language, for me. Symbolic aspect. Because the formal aspect of the you reproduce, but with formal models. It means with public models. The robot has public models, in my opinion. But in this discussion, there is only you have to believe in the human person, because you can say, well, the person has also only public models. You can say both. It's a question of belief, for me. But you have to say, I would say, it's good for me to believe in the human person. It's my answer. It's good for me to believe, and I try to. You also believe in the human person, but I would like that you believe.
But just not to have it discussed, but you also raised upon the idea of human fallibility. So are we going to program into computers fallibility?
Fallibility.
Make mistakes.
Yes.
And that's
Yes,
part of the
yes.
thinking
Well,
about
and also
human.
all the question of random. There are random Turing machines. Well, another problem is discussion of the Turing machine is the only model of. There are new models, but there is a consensus among many computer scientists that Turing machine reproduces.
That what?
Consensus about the church Turing thesis.
Oh.
There is a consensus, but it's not something.
The consensus is about is in favor of the church.
Yes. There is a consensus about in favor.
Javier, I appreciate your faith in the human person.
Yes.
Also, your defense of the human dignity in the man-machine interface is very fine. But if you can also take a slightly critical theological approach to our defense of the human person in this context, I feel actually we are presupposing a slightly negative theology of the God of the gaps.
Yes.
Because humans are unique in such and such respects,
Yes.
still there is room for divine action. Therefore, the divine is defended and the dignity of the human is defended. That is fine. But if some of the hypothetical situations that are present-day neuroscientists or astronomers, and they are predicting, like Stephen Hawking's prediction of the post-human human,
Yes.
or Kurzweil's prediction of the thinking emotional machines, if they become true, such sort of a picture of God would be much outdated, I think.
Yes.
Therefore, I would suggest in the
Our,
science theology dialogue between artificial intelligence and religious belief, a much more metaphysical framework, a much more ontological grounding for reconciliation between the two. Like in terms of the Heideggerian manifestation of being, technology as something profoundly a manifestation of the hidden powers and potentialities of nature, which God has already imprinted on matter or in the laws of nature. If such a metaphysical approach is coined, I think even in any adverse circumstances of the technological breakthrough, which may sit awkwardly with religious belief, religion will withstand, I hope.
well, about the objection of the gaps, filling gaps with, I think the machine can imitate for me, I would be, yes, I would have to discuss the metaphysical approach, but I would like this metaphysical approach, because the problem is not to imitate. Probably everything can be imitated. The problem is what is real for me. What is imitation? And there is a metaphysical problem. There is a metaphysical problem.
Well, in your description of the spirit, there is too much of this metaphysics coming in, I think.
Yes.
But problem with me is the spirit is too theological and too Christian.
Yeah.
We need to be coining
Well,
secular metaphors.
do you know about two Christian? Is Trinitarian, but you know this Catalan Paniker speaks about you know Paniker, yes.
Yeah.
Paniker he speaks that he's Trinitarian also. I would be Trinitarian, but Trinity you can find in other religions also. Paniker means, but I need something like Trinity. I need.
He's right. When you talk to Iris, when you talk to on Star,
yes.
yeah.
Yes, I know.
The metaphysical.
Yes. Well, in my book, I have the second chapter is about language for metaphysics and religion. Language for metaphysics. And the problem in metaphysics, I don't like to use this word, metaphysics, because it's very polemical. It's very polemical.
Javier,
Oh, sorry.
I will
Speak loudly, please, because we don't
in
have
the
a
last
microphone.
part of the exposition, I perceive something like an extrapolation. I am not saying that you are wrong. I am saying that I perceive something like a jump, an extrapolation.
Yes.
You move beyond what you were saying in the first part.
Yes. Well, there is this problem. When I spoke about, I'm studying this now about the mathematics in theology.
Yes.
I need culture and there is this very Catholic. It's very Catholic inculturation. It's a word the typical of the Catholic theology, inculturation. But if you use this word inculturation, culture is necessary for theology, and we have not only to inculturate in other religions, in other cultures, but we have to inculturate in this world of science and technology, and to inculturate in this world of science and technology is science and technology now. It's a mixture, a very strange mixture, postmodern mixture of formalism and intuitive creativity.
Yes.
Intuitive creativity. And I think here is a word to say from, I would say, a Trinitarian point of view.
Yes.
There is a word to say, and there is something culturally different from 100 years ago. 100 years ago, mathematicians were they were foundationals. Foundationalism was very important 100 years ago. Now nobody believes in this, but the problem is how we behave with this mixture of creativity and formalism, because formalism is becoming more and more important. Technology makes formalism important today, but at the same time we know that formalism is not enough.
Barbara.
I would just make an observation. I mean, I appreciate the fact that we're grounding this discussion in belief of specific features of human thinking. And we're making a distinction between a public language and a private language. But when we talk about the computer interacting with us, and the examples, I haven't seen her, but it sounds like we're somehow programming the computer to behave in a way that's consistent with empathy. And I think the behavior of empathy and the behavior of intuition is different from real empathy. And when someone interacts with me in a way that makes me feel like they are responding to me in a human way, that's a behavior that I'm responding to. But I still, and it's probably in the realm of belief, I still stand back and question whether the computer has intuition or empathy or belief, consciousness in the same way that humans do. It's a behavior that we're working with as we're working through language. It's simply an observation. It's not necessarily a question.
I was quite impressed by your illustration of the Chinese, relating to the Chinese language and trying to relate to the Chinese culture. It is really quite foreign in some sense. We have Chinese friends, we have some Chinese here, and Indian. It's taken me a long time to understand the importance of the cultural side of empathy. And I think this illustration of the difficulty of understanding Chinese and making it, trying to approach it from a machine point of view, really emphasizes this problem.
Yeah.
Because a machine can't do that.
Well,
A machine can't achieve the empathy that a human being can. Can it?
well, this is the question.
I would like to make a comment that I think when you talk about the imitation game of
Yes, imitation
Turing,
game.
then you're beginning to talk about what you can do objectively,
Yes.
empirically,
Yes, yes.
which can be verified by
Yeah.
other people.
Yes.
And it seems to me that what is distinctly human
Yeah.
is the awareness of what we are doing.
Yes.
And that is something that is an immediate personal perception that another person cannot have of my awareness.
Yes.
The other person can verify
Yes.
how I'm reacting, what
Yes.
kind of actions
Yes.
I'm doing, but cannot verify that aspect
Yes.
of awareness. That seems to me, that consciousness is
Yes.
a very fundamental aspect of reality,
Yes.
and we have to take that into account.
Yes.
It cannot be empirically verified.
Yes.
This comes back to the question of Bishop Berkeley, the solipsism, that he doesn't believe in the existence of other beings. There's no way to prove the existence of other beings, but it's a fundamental reality that we have to accept.
Yes.
And the same thing, that other human beings have this same experience, this personal experience of awareness, is something that it would be crazy not to accept that.
Yes.
But we cannot verify it empirically because
Yes.
it's an internal experience. It's
Yes.
an experience of a completely different order.
Yes.
And I think that's where our spiritual nature as human beings comes in.
Yes.
And that is something that is verifiable. When
Yes.
someone denies the existence of the human soul, they are just overlooking completely that experience that they have
Yes.
of awareness, of consciousness.
Well-
And this is different from what you can measure externally, whether
Yes.
it be empathy, whether it be intuition,
Yes.
whether it be thinking.
Yes, but the question remains, what is awareness? What is consciousness? For many neuroscientists, consciousness is epiphenomenon. Something
What does that mean to say?
yes, something that don't belong to neuroscience.
Okay, it doesn't belong to neuroscience because neuroscience
Well, yes.
is dealing with what you can observe and verify
Yes.
empirically,
Yes.
objectively.
Yes.
But this is something that is the very
Yes.
nature of it,
Yes.
such that it cannot be verified empirically.
But awareness somehow can be reproduced by a program in a robot. A robot can be conscious of how he will react, and he can modify
How
his...
do you know that?
Well, a robot can know his own program.
That's different from consciousness.
Yes, yeah.
That's something that you can measure.
Yes.
You can measure that the memory of the robot includes perception, includes sensors that sense different aspects of the robot. But to say that there's consciousness, that there is that experience of awareness, that's an assumption. For us, who are all human beings, it's a good and a natural assumption to assume that other people have that experience. But to suppose the robot does, that's a very interesting open question. And unfortunately, it's impossible to verify, to answer.
You want? Oh, sorry. Here. Yeah.
So, Javier, thank you very much. Your presentation was very not only enriching, but it also raised very many questions. Only one question I want to ask you is, are you familiar with this question? What is it to be a bat?
What is it to be?
To be a bat. B-A-T. Thomas Mann. Okay, no problem.
Murciélago.
Sí. Well,
See, the whole question about, the real empathy and the apparent empathy.
Yes. This is why I speak about virtual and real.
Yes. But now the problem is we are more influenced today by the virtual than by the real.
Yes. Probably.
How do you react to that statement if it is true in the light of your presentation?
It's true what?
That we are more influenced
By
the virtual than by the real.
Yes. Well, I am an optimist always, and I believe in computers. I believe in computers, and I believe that the real world can imitate anything. But imitate. Can imitate anything, and this will be very good for humanity, in my opinion. That's why I have put these two circles, and in this interaction, well, I could admit also a moment of singularity. Well, why not? There are many problems, but why not? We admit a moment of singularity, but we humans, we control. We have the control of this moment belongs to us. The moment of singularity. Well, this moment of singularity will be when the virtual will help so much the real that we make a big change. But the real will be always real.